Okay, so welcome everyone. Welcome to my channel. So, like I mentioned earlier, that we solve the sine and the cosine. I promised to create a separate video. So we'll continue differentiating by first principle. This time we'll try to solve the sine function and the cosine function. So how do you solve if you have a sine function? Okay, so just do a quick recap. So we said differentiating 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 by first principle. Okay, so differentiating by first principle, from my earlier videos we said that we will have a function which is prime. So prime, it means dy dx, for those who don't know. So if you say we are talking about differentiating the function using first principle, we use the formula limit as h approaches to 0, f x plus h minus f of x, and you divide by h. Okay, so hope you guys remember this formula. Okay, yeah, it's of great importance that you can remember this formula. Okay, so continue solving. So today we'll solve d. So this is our d. So d is f of x equal to sine 4x. Okay, so we are trying to differentiate using first principle. So if you remember, we first find f of x, which is the question given. Then next we solve for f x plus h. So where there is x here, we substitute with what? X plus h. So this becomes sine 4. Where there is x, put x plus h. Okay, so x plus h equal to sine. So we just distribute the 4, so it will be 4x plus so 4x, 4 multiplied by h, to be 4h. Okay, so we can't leave it like this. There are some identities which you have to know. So if, for example, you are trying to solve for sine A plus B, so this is an identity, double angle identity. So this is the same as sine A cos B plus sine B cos A. So you're swapping. Here sine has A, here sine has B, here cosine has B, here cosine has A. So you swap. You can start with this one or this one. So you have to know this identity. Okay, so that you don't have to have a miserable life. Okay, so just have to know it. Okay, so we have f of x plus h equal to sine 4x plus 4h. So we have a and b. Okay, so this, using the double angle, we say sine 4x cos 4h, then plus, now the sine will have what here, so it has 4x, so here it will have 4h, so sine 4h cos, so cos at 4h, now it will have 4x. Okay, so f of x plus h is equals to, so sine 4x cos 4h plus sine 4h cos 4x. Okay, so now we apply the formula since we have f of x and fx. So the formula is, if you are differentiating f of x, you take the limit as h approaches 0 of f of x plus h minus f of x divided by h. So the beauty of expressing it is in this form. We know f of x is what? F of x is just sine 4x. So we're just trying to find another 4x so that we can group the two terms and simplify our equation. We can't just write it in this form because this form is not very useful in this case. So we need to write it in a useful form. Okay. So we continue. So here equal to limit as h approaches 0. So fx plus h is sine 4x cos 4h plus sine 4h cos 4x minus, so fx is what? Sine 4x. So we divide everything by h. Okay, so I'll continue solving. This is equal to, so we group the sign, this sign here and this sign this side. Okay, so we write limit as h approaches to 0. So let's write the sine 4x. So I'm taking out this side. So it will be here, what will remain here, cos 4h. Then this will be just minus 1 because sine has gone outside. So minus 1. Then we have this function here. Plus, this is what? Sine 4h cos, this is cos, okay, cos 4x, yeah, so like this, over h. Okay, so let me just rewrite this. Limit as h approaches to 0, sine 4x cos 4h minus 1 plus, so sine 4h cos 4x over h. So this is f x prime. Okay. Okay, so we continue. Now, after reaching this point, we will rewrite this equation in a form where we separate the functions which have h and those which don't have h. So what I mean is x prime is equals to, so sine, we can sine x, sine 4x, it doesn't have h, so we can write it multiplied by then this function cos cos, is it, okay, cos 4h minus 1, so this is over h, then plus, even here we can more like split the cos for x to be a little bit alone, then we have sine 4h over h. Okay, so this is the same. You know, this is what is here. Here we've just separated the cos x and the sine x. They are all divided by h. Okay, so the reason why we are doing this, we want to come up with an identity. So the identity which you guys have to know is the limit as h approaches to 0. So we also have some standard identities. Okay, so the limit as cos, let's say a h minus 1 over AH. It has to give you 0. So A can be any number. Okay? So also the limit as H approaches 0, sine AH over AH has to give us what? 1. So you need to know these functions. Okay? So A can be any number. So remember from our previous video, so we check what is A, the value of A. You need to find a way on how to bring A here in the denominator. Even here, we need to find a way on how to bring A. So here, these equations, these two, if you apply them now, so we have sine x. Sorry, I've forgotten to write the limit here. Sorry, h approaches to 0. So let me do that. Write the limit. It's my rubber. My eraser. Okay, so I can rub here. I can rub here. Right. So here there has to be a limit as h reaches to 0. So it's equals. So here limit as h approaches to 0. So I'll write sine 4x. This one we have no problem with it because it doesn't involve h. So cos 4h minus 1 over h plus cos 4x multiplied by sine 4h over h. Okay, so for those who remember, if we have a number here, a, how do we bring down the 4 here? How do we bring down the 4 here? So here we also have a is 4. So how can we get the 4 to h? So you multiply the numerator and the denominator by 4, for those who remember. Okay. So this equals to limit as h approaches to 0. So here we'll say 4. So we'll have 4 sine 4x. So you are multiplying this 4. So if there was 5, you would have multiplied 5 on the numerator and 5 in the denominator. So we want to use the identity, then cosine 4h minus 1. And then on the denominator, 4 is multiplied to h. So now we've gotten this equation, this part. So we are multiplying by 4 on the numerator and denominator so that we can have it in this standard. There is 4 here and there is 4 here. So now this will be 0, meaning this will go to 0. And then plus cos 4x. So how can we get 4 down here? Same thing, we multiply by, so sine 4h, running out of space. Okay, do I have another page? Okay, so I will write here 4x prime equal to, so write limit, sorry, I don't know why I keep on forgetting writing it. Okay, limit, so we have 4 sine 4x cos 4h minus 1 over 4h plus, okay, so this part, why I didn't insert the page correctly. Let's see, where is my previous work? Oops, I inserted the pages on top. Okay, so let me just try to insert now. Where is the page? Check again. Setting at the bottom. Okay. Okay, so this is our equation. Okay, let me just rewrite it nicely. Plus, so here there is 4 cos x, then sine 4h over 4. So here we were just trying to bring this sine function and the cosine function into standards. So the standards are these: limit as h approaches to 0. So if you have a function cos ah minus 1 over ah, this function will give you 0. So how do you bring the a down if the a is only here, which has no a? You multiply the numerator and the denominator by a. Okay, so this is what we are doing. A is 4. So we multiplied 4 numerator, this is the 4. Denominator, this is the 4. Here, same applies here. We're trying to bring the a down. So you multiply by 4 on the numerator and 4 at the denominator. Okay. So hope you guys are following. Okay, so let's continue. So that's about bringing the denominator and the numerator to have the same value. So this will go to 0, this part will go to 0, and this part is going to be 1. So sine x, making a mess. Okay, let me just do this. Okay, so we have f of x, okay, prime equal to so limit as h approaches to 0. So we've said this part will go to 0, so this multiplied by 0 to be 0. Then cos, oh, this is 4x ish. Okay, 4x, then here there is a 4, this part, okay, multiplied by 1, because this is an identity to be equal to 1. So this is same as the limit as h approaches to 0, 4 cos 4x. So this is independent of x, so we'll just drop the limit since it doesn't apply here because there is no h here. So your answer is 4 cos 4x. So this is our answer. So it's just about knowing the identities. Okay, so the identities which you have to know, I've said the limit as h approaches to 0, cos minus 1 over this is equals to 0. Then the limit as h approaches to 0, sine over is equals to 1. Okay, so these you have to know it. You need to know these formulas, and also sine a plus b is equal to sine a cos b plus sine b cos a. So we're just swapping. Here cosine had b, here it has a. Okay, so let's answer the last part, the cosine. So you've answered the sine function. Now we come to the cosine, so e. So part e says f of x. We know f of x is equals to so cos 2x. So now we get f of x plus h. So where there is x, we put x plus h. So cos 2x plus h. Okay, so we expand this. This is same as cos 2x plus 2h. So this is not much useful. We need to use a double angle identity. So cos a plus b. You need to know also the cosine function. So this is cos a cos b minus sine a sine b. So you just have to know this one is different from the sine function. So you have sine, first of all, cos a cos b, then minus sine a sine b. Very easy to remember. Okay, so now let's write. So we have fx plus h equal to, so you have cos 2x plus 2h. So this can be your a, this can be your b, meaning this will be cos 2x, which is this, then cos 2h, which is b, minus sine 2x sine 2h. Okay, so we are writing it in this because it's not much helpful if we take it like this, but it's helpful if we write it like this. Now we apply our formula. So first, differentiating by first principle is limit as h approaches to 0. So you have f of x plus h minus f of x over h. So now let's substitute. So this is equals to limit as h approaches to 0. F of x plus h will have cos 2x cos 2h minus sine 2x sine 2h minus f of x. What is f of x? Is what? Cos 2x. So cos 2x, we have 1 here and 1 here. So we will group those. The next step we group them. Okay. So we have this. Next we write f of x prime equal to limit as h approaches to 0. So we're grouping the cosine. We're taking out the cosine, cos 2x. Okay, so here you have cos 2h here, this one. Okay, minus this will be 1. Okay, so 1. Then we have minus sine 2x sine 2h, everything over h. So remember, we now try to separate those with x and those without x. So the h, so we just more like split them out. So you have limit as h approaches to 0. So cos x, we will split it a bit, is multiplied by this cos 2h minus 1. So over h minus here sine x, take it out, sine 2x is being multiplied by sine 2h over h. Okay, so just split. The h is a common denominator for this and this. So the h here is the same as it's also the denominator of this, because this is just over 1. This multiplied by this, it will be the same. 1 multiplied by h, it will be just h. So next, for those who remember, how do we get this coefficient here, 2, to the bottom? You multiply both the numerator and the denominator by what? 2. Even here, how do we get the 2 down? We multiply the numerator and the denominator by 2. Okay, so this same as limit as h approaches to 0. So on top, we'll just multiply by 2 cos 2x, okay, cos 2h minus 1. Then this will be over 2h. 2 on top, 2 down. Okay, minus 2 on top, sine 2x multiplied by sine 2h over 2h. Okay, so here this limit applies to both these functions, this and this. So now, for those who remember, I said there are these identities: limit as h approaches to 0, cos a h minus 1 over a h. This will have to give you what? 0. Then limit as h approaches to 0, sine a h over a h. So we were multiplying by the 2. We were trying to get this to conform to this standard, because like here there is no 2 here, so we can't use this identity. The coefficient of h has to be the same. No wonder we are multiplying by 2. So if there is 3 here, we multiply by 3 on top, 3 down. If there is 5 here, we multiply by 5 on top, 5 down. Okay, so we know this is equals to 1. So we know this part will be 1. This part will be 0. So 0 multiplied by this part will be 0. So applying these identities, we'll get limit as h approaches to 0. So if you apply the limit to this, it will be just 0. So you have minus, there is minus here, 2 sine 2x multiplied by, that will be 1. So f of x equals to limit as h, which is 0 minus 2 sine 2x. So f of x prime, this doesn't have h, so meaning the limit is just laid off, sine 2x. So this is your answer. So this is how you solve functions which contain cosine and sine functions. So a little bit of takeaways: you need to know these formulas. So sine A plus sine B, this is the same as sine A cos B plus sine B cos A. Okay, then you have cos A plus B. This is the same as cos A cos B minus sine A sine B. Then limit as h approaches to 0 of sine AH over AH is equals to 1. Okay? Then the other one, last one is limit as h approaches to 0 cos AH minus 1 over AH is equals to 0. So this is just a little bit of takeaways which you guys have to know. So continue studying. Make sure you verify the answers. Yeah, so where you feel you are not clear, you can always reach out. So thank you for watching my video. Continue subscribing, inviting more friends. Thank you. So end here for today.